Hello everyone, welcome to this video which we will be talking about structure exception handling, SEH. This is going to be a very long video, so make sure you have all what you need, coffee, whatever, water. It's going to be a long one because we'll do a lot of different, let's say, tests to learn a lot about the different ideas and concepts, not just how to exploit a structure exception handler, a case where SEH is used, or yeah, we will be talking about a lot of different things. So make sure you have a lot of coffee, water, whatever. Okay, makes you stay focused. So that way uh, we can we can work on this together. So what I will be doing is first we will be talking about SEH for sure. So we'll talk about intro to SEH, and we will see that from Furlan's blog. We'll go over that from there. We will modify our test.c code using concepts from Corlan. Okay, so blog, and I will show you what I mean by here. Do different experiments using Visual Studio and compiler, linker options. We will play a lot with those. We will see what they are. So let me save this to my desktop. SEH notes, let's call it like that. Okay, so what else am I going to be covering? And then definitely we are going to be exploiting this. Exploit. Or first, by the way, we'll try to exploit without yeah, let's just try to exploit the application. Okay, so that's what we are going to be doing. I will keep adding notes here as we go through this. Okay, so let's first go to our documents, I think, and yep. So I'm going to create another directory. I'm going to call it test. Let's call it SEH test. This is where I will, let's say, copy my, do I need to do this? Yeah, maybe I just don't want to modify other code. So let me copy this one. Okay. I'm gonna open another one here. So by the way, I installed Visual Studio, I think the Express version, which is free. You can do that. I did try using MinGW, but by the way, I used this, I think, for other things. So you won't be able to use MinGW for SEH cases because this does not support that. And SEH is a Windows thing, so make sure you install Visual Studio. So we have this. Let's see what exploit is this one, because I think we'll need, yeah, I'll use a base. And what is this one, by the way? So let's just check this one because I need a base to work with. Okay, so yeah, we can use this, especially that it has the exploit at the end, the shellcode. So let's call it SEH1. Okay, I will modify this. Let's open it. And I'm going to leave the shellcode here because this is not what we need. We don't need any of this, by the way. We don't know the buffer size for now, so we will not be using this, but at least let's mark it out. And yeah, I need the path to the whole application. Let me just get the other one. I told you once I'm a little bit lazy, so now you can see how lazy I am, because I'm going to copy this one all the way to the end and just put it over here. Okay, so this just shows you how lazy I am. Okay, so if we go to the end, let's see, we'll call ours SEH test. So let's name it that way. And yep, let's get this ready. So this is our SEH. We'll come back to it later, but at least for now, excuse me, SEH test. Yeah, I could have done all of this, by the way, and not get you confused, but I don't know. Again, I'm lazy a little bit, or maybe more than a little bit. Okay, so let's get the Visual Studio. So let's get our Visual Studio here, and let's create a new project, and we'll use an empty one. So empty, next. I'm just gonna call it SEH test, and then I will copy the code we have in test into this code. So here, source, add new item, and yeah, C++, I like to call them main. And yep, I'll just put it like this. Okay, so all good. We no longer need this anymore. But if we go to the browser, we can, I will add this, by the way, later to the, let's say, so this is Corlan's blog. I will add it to my YouTube video, so you'll have that, and also to the repository. Okay, so here it talks about SEH based exploits. This is actually all of this video. I would say depends on this. So if you can go over this blog, you'll learn a lot from it. But the video is also gonna hopefully help you understand a lot of this. So SEH, think of it like this. You have some structure exception handling. Let's talk about handlers in general. So developers, usually what they do is inside their code, they will add like a try catch or a try except block of code. And what that will do is it will try to run some code in here. Okay, so this between these brackets, it will try to run some code. So when the system executes the application, it will try to run this code. If something happens, you are telling the application or the system which is running the application, if something happens here, go do this. So let's say if anything happens here, I want you to do this. So let me just give you an example. You run an application which needs some internet connection. So you try to run the application that requires some internet. If the internet connection is not available, then the system will like say maybe just give you a pop-up message saying, hey, you don't have any internet connection. So that way you know, oh, okay, the application is not running because of that. So you developers usually will use a lot of these. And again, the idea is to, if something happens within this block of code, you want to handle it and not let the application crash. So the whole idea behind all of this is to prevent the application kind of from crashing. So the developer will put, again, these try catch or try except blocks in order to do that. Okay, now Windows has what they call a structured exception handler. So this is a Windows thing, okay, which is what we call a SEH. So it will try to catch these exceptions, and it will try to run the code that will handle those exceptions. If, let's say, if you have if it tries to run the first code and it let's say it doesn't work, then it will try it will see if there are other handlers, or if there is another way to handle the situation and not make the application crash. If there is, it will try to run it. If there is not, then it will move to the end of the what is called the list. This is actually like a linked list which gets added onto the stack of the application. Okay, each thread of the application will have this SEH kind of let's say linked list. Okay, so again, what happens is the application, something happens, so the system will try using SEH to handle that situation. If it can, then that's good. Then the application can continue. If it can't, what will happen is it will look for the next structure exception handler. So it will look for the next handler. And then if that handler can handle the case, that's great. The application can continue. If it can't, it will look for the next one until at the end there is no handlers left, and that's when the application will crash. So as you can see here, we have the address to some handler code, and that's when an exception happens, this code will be called. And again, if you have more than one handler, then they will all be added to the stack. Okay, so make sure you read this blog. It gives you a lot of details about exception handlers and more details about that. Okay, now once you let's see, what do we have here before I continue? Yeah, so this is what I was talking about. So this is the stack, and as you can see here, each one of these, by the way, is a record. So these records have each record will have two entries. Each one of them is 4 bytes, by the way. So the first 4 bytes is the pointer to the next structure exception handler record. So this is, and that's why it's a linked list. So the first 4 bytes points to the next entry in the list, and then the next 4 bytes. So again, we have 4 bytes. The next 4 bytes is actually where it points to the code that will try to handle that situation, that exception that happened. So if something happens, then we will go to first one, this one, execute it. If it works, or if we can execute it and it can, let's say, solve the problem, then that's great. The application will continue the execution. If it can't, then we already know where the next one is. And the next one, we try to execute the code. If it can work, that's great. The application continues. If it can't, this will point to the next one. And same thing, we call the handler. The handler, if it was successful, it will execute the code, solve our problem. If it wasn't, then we'll go back. And as you can see here, these FFF, etc. This is where you know that we are at the end of the exception handler list. This is the end of the chain. This is a chain. This is where we end. This is where the end of the chain is. Okay, and this means now that I'm going to call the default exception handler, and usually the default might terminate your application. Okay, it might terminate the application. So there's the segment pointer, or the thread environment block, always points to the beginning of this chain. So if you go to the thread environment block at fs0, this is always pointing at the beginning of this SEH chain. Okay, so if someone says, how do I know where this linked list is starting? All you need to know is you'll need to dump the beginning of the fs0 from the thread environment block or thread information block, depending on where you read. Okay, then this will be pointing to the first entry of your SEH chain. Okay, the last entry again is the FFFFFFF. Okay, that's the last entry on the list, and that's when the system knows that it reached the end and it wasn't able, let's say, to solve the problem, so the application will be terminated. So please also make sure you go read this blog. It's a really good one. So why I wanted to come here is because I want to use the same concepts that Peter has used over here. So as you can see, he created these exception handler code. So I will use lots of the code that he's using. I'm just gonna, let me put them over here. So first, let me copy this. I'm gonna do a little bit something different, by the way, but at the end, the same idea. I'm gonna so I'm gonna do I'm gonna call this main. Okay, I'm gonna call this one main, and I'm gonna create another one, call it, I'm I'm gonna add one to function one exception handler. So we'll add one here, we'll add one to the main. Okay, so he's using 512 bytes. I don't need any of that. We can get that. Okay. Okay, so here I'm not gonna check for this anymore. Okay, I'll use an exception handler. So we'll use try, and then yep, we can do this and put this in some exception. Okay, so we'll try to do that. There's no need for the else anymore, and we'll do the accept. Okay, and with the accept we will call function one accept, and I'm gonna do this. Okay, need to do that, and then there is no code in here, so yep, this one I'm gonna disable it because we will add the code into the handler. And what do I need to do next? So we defined these, but we didn't create any code for them. Okay, so let's do this. And so here, yeah, this was with main. I'm gonna call it main exception handler. I'm gonna just add some message here. Happened in main. Okay, and actually, by the way, I'm gonna just copy this. And so this one is already done. Okay, now I'm gonna just add this one over here. And I don't really need to put it after it, yeah, but I'm just gonna, for organization, happened in function one, and let's put these here just in case they work. Okay, so exception happened in main, exception happened in function one. Now what we need to do, so we've configured main to use the exception, and yeah, we need to now configure our function one. So let's do that. So try, and again we'll have the buffer. So what I will do is I will copy these to the try clause, and then we'll have over here the accept, right? And then in the accept clause, what we will do is call the function one. Sorry, I did this by mistake. So we're gonna do this over here, right? Because this is function one. I think I did a mistake there. And yep, that's what we need. Nothing here. This should be main, by the way, because we want to call, if something happens in main, then we call this. If something happens in my function one, then we call this one. Good. Okay, so what do we need to do next? I think all should be good. Okay, so let's check a couple of things here. And wait, I don't want debug. I'm just gonna go to release mode immediately. Let me check, and so I'm gonna do a couple of things. Okay, so I'm gonna do a couple of things here to make sure that okay, so if we go to security checks, I'm gonna turn this off, but I'm gonna leave this, by the way, as an exercise for you. I'll tell you about this later, but I'm gonna turn it off for disabling the cookies. We'll talk about cookies later. I'm also gonna turn off control flow guard. We'll talk about these all later in some other module or in some other lab later. Let's see what else do I need to disable here. Nothing else. So if I go to general register debugging, I don't want this. Also, I like to disable them. And then if I go to advanced, and I'm going to disable randomized based, no random base. And I'm also going to disable, by the way, date execution prevention. We will talk about those and how to bypass them later, especially the dip. This one's going to be a tough one. We'll need to modify our code too, but hopefully we'll do that as well. So what else do I need? And okay, oh yeah, we need to disable this safe SEH, especially that it's just one application, so no safe SEH. And so what safe SEH will do, and this is also written in Peter's blog, is it will pre-register the handlers. So yeah, go read about it over here. We will come back to lots of the blog, but where is safe SEH? It was mentioned here somewhere. I don't remember where, but if you follow the safe SEH, yeah, so it's probably mentioned here. Yeah, here. So this is another protection, see, added by compiler. So SEH, it's preventing abuse of SEH overrides, okay? So if this is going to be applied, it will, what will happen is, then what will happen is you will need to find a way to bypass this by finding a module which is not compiled with safe SEH. So again, I highly recommend you you check this out and read about SEH. Where is the details about it? I forgot where it was, but it should be here somewhere. That I think it's either here, but it's probably also maybe in another. So as you can see here, yeah, there's a way around. So all these will be, all your registers will be zeroed out. So you'll see a XOR or an XOR. I like to call it XOR. And that way, so the safe protection, which is means that you can no longer jump to a register. We'll need to find another way behind this. So again, I highly recommend you check this out, since you cannot simply jump to a register because they are XORed out or XORed out. Anyway, we'll come back to this maybe in another blog, I mean video. We were here. Let's continue our code. So we applied this. What else do I need to do? No compat. Yeah, I think that's it. So let's now compile our code and see what's going to happen. Okay, all of them worked correctly. Maybe unsafe, considering to disable. Oh, okay. Yeah, let's add that actually at the beginning. Let's add that, which is define, and then let's do CRT secure no warnings. So we'll disable these warnings, okay? So that way we don't get them anymore. And if we recompile, we should not get that anymore in our output. Great, so we have everything ready. So what we can do now is start our application. So if we run the application, so exception happened in function 1, exception happened in main. You can see those were both called, and you can see which one was called before the other. And So those were both printed. If we look at the code, exception happened. So the try, sorry, the my function one problem happened. So an exception was my function one was called. I hope my code is correct, right? And then this one tried to copy something here, but it couldn't because there's nothing there. So my function one handler also was called. So is our code correct? Let me just double check, by the way. So my function one, my exception. Yeah, I think everything should be fine. Okay, let's do another test. This time say hello. You entered hello, so there's no problem, no exception happened. Let's say our buffer was 16 byte. Yeah, let's try to add maybe something like that. No exception, no exception, no exception. Let's add maybe 2, still no exception. Okay. Oh, everything's working fine, yeah. Right. Okay. No, I mean, let's add more. Oh, okay. So here something happened and we were supposed to see the my exception happened in the function one exception handler. Yeah, we should have seen the code here, but anyway, let's see what will happen again. You entered, probably it wasn't able to run the exception handler. Yeah, because it got overwritten. Okay, so yeah, it couldn't print this function or this message for us because the handler also got overwritten. We will see now in the debugger. But as you can see here, if we write a lot of data, then actually what we are going to be doing is we are going to be overwriting these exception handlers. Okay, so that's what is happening here, is we are actually overwriting these exception handlers. So let's run our application this time with, yeah, have the code. Okay, so if we go back and let's copy this actually to, where is my repository? Okay, here, release. Yeah, let's put it over here so we can run our code directly from here actually. Edit, let's get this. Forget about the shellcode for now. And actually I can remove it so you don't get troubled with it while you're focusing with me on this. So let's leave it over here for now at least. And we have the immunity. This is where the debugger is, and here in the buffer. So now the buffer, let's play with the buffer. So buffer will be, if you remember, this application was crashing at 28, but let's just send, because it's the same code by the way, so let's just send let's send first maybe 16 bytes, see what's going to happen. So if we run the code, it should start our debugger. Okay, and in post state. So now, by the way, if you go to view and the SEH chain, you'll see that immediately the system automatically adds these handlers to your application. So if we go back, by the way, and if we look at the stack, so see, the first one was the first one was at address ffcc, and this is pointing to the first 4 bytes. And if you remember from from Peter Corland's blog, the first 4 bytes is a pointer to the next, and then the next 4 bytes is pointer for the handler. So as you can see here, the first 4 bytes is for the next, and as you can see, pointer to next SEH record. So FFE4, if we go down here, FFE4, it's pointing to the end of the record, right, end of the chain. and then the next 4 bytes here is the handler. So this is where the handler of the first record, is going to be found. So this is where the code, if executed, so if we go here, this is the code that should be handling if this, let's say, handler is to be kicked in and to start. Okay, if it doesn't work, then the pointer will point to the next one, which is this, and this is when you know that we reach the end of the SEH chain. So as you can see, we saw them from just going by view SEH chain. You can do that. Now another cool thing in Mona, so if we go to Mona, there is, yeah, you see here SEH chain, show the current SEH chain. So if we say Mona SEH chain, okay, so it will dump also. So see, it will dump the SEH chains, telling you that the address 19FFCC has the next SEH chain is this one, FFE4. We already saw it on the stack, and this is where the handler is. So if we go back to C, you can see here, this is where the handler is, B150. We go back to the log here. Handler is at B150, 7746 B150. And then the other one is at the address FFE4. We said that, and you can see the next is these FFF, etc. And it means this is the end of the chain, but the handler is at A101. So if we go back here, we go down, we can see that this is at A101, which is the last handler, okay, which will be called. Okay, so everything looks good. Now if we start our execution, by the way, so if we start the execution, and let's see now, if we go to our SEH chain, we can see still nothing happened because we still haven't, let's say, let's start our program. Gonna run some code. I just want the pointer. See, this one got kicked in, so we can see it got kicked in. So if I go, sorry, to view SEH chain, we can see that now we have the one that was in our code got added to the stack. This one got added to the stack. Okay, so if we go do this Mona SEH chain also, so if we do that, we can see this is where the next SEH chain now is. So this is the address of this one, and it's telling you that the next SEH chain is at FFCC, which is this one, and the code for this handler is at 00401127. So if we go back here, we can see that FF60, the address, is pointing to these 4 bytes. These 4 bytes include the pointer to the next SEH chain. So if we, and then this is where the handler is, 1127. So now you can see that we were able to use Mona also to dump the first pointer and to the first, let's say, entry to this whole linked list of structure exception handlers. The first 4 bytes points to the next one, the next 4 bytes points to the handler, and then the next one points to this, and then the 4 bytes point to the handler, and so on and so forth. So you can see now that this is the chain. So this one's pointing to this, which the next 4 bytes is the handler. And if we go to FFCC, we go down, we can see at FFCC is where our next record, SEH record, first 4 bytes are pointing to the next one, and then the next 4 bytes pointing to the handler. Okay, same thing here again at the end. So FFE4, this is where FFE4 pointing to the end of the chain, and then the next 4 bytes is pointing to this handler. Now another thing that Mona has, which is also cool, we can see at the beginning here is you can put a breakpoint on all current SEH handler function pointers. So we can put a breakpoint. So what we can do here is B breakpoint SEH. So if we do that, and now if we go to our breakpoints, we can see that there's a breakpoint has been added where to our SEH. Okay, so there's a breakpoint being added there. We continue the execution. Okay, nothing happened. We didn't we didn't run into a problem because there is no exception happened. So we didn't hit the breakpoint. But let's now run the code and add maybe more A's to it. So let's run the code, but this time instead of 16, let's add, for example, 28. I think 28, if we remember from the last time, that's how much we needed to exploit this application. Okay, you can also, by the way, use the code that Peter has, but then you'll just need to increase your amount of data you pass, because here he's passing 512, so it's a little bit going to be different just in size, but the same ideas are going to be applied. So again, if we run F5, this time our buffer is 28. Let's see what's going to happen. And again, now if we look at our Mona SEH chain, okay, so if we do that, we can see those from the kernel. And if we start our application, so let's start the application, and the application terminated. Okay, so yeah, I should have done, but also it didn't cause an exception, by the way, which yeah, I wanted just to show you again, let's say the exception. But what I will do this time is before I increase the buffer, let's run it, by the way, without a buffer, because if you remember in the code, we also have an exception in main if we don't receive any variable. So if argument 1 is empty, we should hit the exception. So let's do that. And this time what I will do is I will just delete the buffer. So I'm just going to do that and run the code again. Buffer is not defined. What did I use buffer here? Oh, okay. A lot of modifications. Okay, so this time, okay, so if we do Mona SEH chain, okay, we should see the main SEH chain. Okay, so let's continue the execution. Let's do these calls, and now we should have, yeah, we can see the SEH chain handler has been added to the stack. So if we hit this again, we could see now our SEH exception from the application has been added to the stack, and also again you can see it in this fancy window here. You can see it here, and if you go to, yeah, we can add a breakpoint on this one, or follow address in stack. Yeah, we already know that address is here. Yeah, no problem. So let's continue. And now if we put Mona breakpoint SEH, let's put a breakpoint on it. Let's see if there's a breakpoint. Yep, there is one here. So if we continue our execution and then hit F9, so now we get the access violation. So an exception happened now, and why? Because we are trying to run the code without passing any value. So we are trying to pass this to my function 1, and this is empty. So this exception is happening. So here we have 1072. See, we go to the exceptions. Now we have multiple of them. So probably all of them got added to the stack, all of the exceptions that we have. But now let's run the code. So if you look at the where is this? Yeah. you look at saying access violation, shift F7, F8, F9 to pass the exception to the program. So that's what we want to do. So if we do that, now we hit where our breakpoint, see the breakpoint, 11:27. So we arrive to our exception. So we are now actually at our exception. So if we continue the execution, it should like do, see, around the exception. But yeah, nothing's gonna happen because at the end, by the way, we don't have anything here, so nothing's gonna happen. So at least I just wanted to show you the exception. We close now. This time let's modify our code. Okay, so let's go back 28. Let's say we overwrite this one with 1000 ace, and if we run that, so I'm gonna do something here, and you'll see that why I mentioned that we will be playing with the compiler option. So we have already done that, but there is one thing that's going to happen here, null byte. So we'll need to, yeah, I'm not going to ruin the surprise. Let's see what's going to happen. And again, the idea behind all this video is to just explain a lot of concepts and see how to learn about them, and we'll bypass the exploit, but we'll need to modify let's say one thing in order to do that, and I will show you what that is. I know we've already modified some of the compiler and all of those protections, but again, we'll add those later in future videos, and we'll bypass them one after the other. Or at least hopefully we'll do that when I find time. So again, if we execute the code, okay, if we execute the code, if we look at the stack or the exception handler, so we see our main, the ones that come from the system are already added, and then this one got added after we executed the code. So now if we, what we can do is, let's see if we can breakpoint SEH. Let's do that just to see, do we have everything? Good. So all good. And let's see now what's going to happen. So we run the code. We are at here. It's telling you we need an exception happen. So we need to pass the exception. So now what happened is we are at the exception, right? And if we look at the, so if we continue the execution, okay, and if we continue our execution, we are back at the, this is another exception, I think, right? Let's do nona SEH chain just to see. 150, is it another 150? Yep, so this is another exception handler. Okay, so if we go back and continue the execution, okay, continue execution, continue, bypass the exception, okay. Did we, application terminated? Huh, what happened here? Oh, I know what happened. I forgot, by the way. Yeah, I forgot to do. Okay, my fault. Again, that's why these are all crazy things. So if we go back, we forgot to put, by the way, the buffer. We didn't send the buffer. I was wondering why, where is my 1000 bytes? Good, so now, yeah, crazy. So now if we, again, if you want to check, you can nona SEH chain. Okay, we'll see only two of them, the NTDLL ones. Okay, so if we execute our code, let's do a couple of execution. We check the chain again. We should see that now we have some handlers. Let's add a breakpoint SEH, so we can do that. And we can check our breakpoint here. Good. So if we go back and if we continue the execution, okay, what will happen is, great, we arrived at the breakpoint, and we can see the data got copied. By the way, if you want to trace this, you can do that. I'm not going to do the tracing, but I highly recommend also you do this to see how those bytes are going to get written here. Now I'm going to pass the exception. So if we do F9, sorry, if we do like it says shift F7, F8, or F9, you can also do shift F9. What will happen now is EIP gets overwritten with what? With the A's. Why? Because if we look at the SEH chain, the SEH chain, it's trying to run EIP, right? It's trying to run the handler, and the handler actually got overwritten with what? With the 41414141, which are the A's. So we overwrote the exception handler. We managed to control EIP, excuse me, we managed to control EIP by overwriting the exception handler. Let me just do this one more time so you can understand the idea again before we continue. Run. If we run this, and yeah, so if we do a couple of executions, okay, let's check mana SEH chain, see what we have. Okay, so ours was added because we got it executed. Let's do breakpoint SEH, so we can add a breakpoint. Okay, and again, you can trace, by the way, the code. I highly recommend you do that. I'm gonna just jump over most of the things, okay, because I'm interested now in the overwrite. Actually, maybe I can at least, yep. So now we arrived at the we triggered an exception. Okay, we triggered an exception, so it's trying to now do this execution. If we look at the SEH chain now, you can see it got overwritten. If we also look at now from here, so look here, the our chain, the first one was 40 11 27. So if we do mana SEH chain again, you should see now that it has been overwritten. See? So the FFEC1, FFE, yeah, these what is it? Yeah, these were overwritten now with corrupted data. Okay, so they don't point anywhere. So this is how you will be able to control EIP this time, is by overwriting the SEH chain. Okay, we pass the, so if we say we are going to pass the handler to you, here it is. So we feed EIP with the A's. So now what the question becomes is, how many bytes do I need to overwrite in order to reach these 4 bytes which get stuffed into EIP? So we need to find the offset, similar to what we were doing, by the way, back before. So we can also use Mona again, okay, and use the, what is it, the pattern create. So Mona pattern create 1000 bytes. So it's going to create the pattern for us. And if I open this in another one, so got changed. Okay, so it seems it got changed over here. No problem. So let's copy these now and go back to our code. And then this time, instead of this, we'll send the buff with the 1000 bytes. Okay, so if we run this again, let's close all of this. And if we run this again, so we are gonna send a buffer of 1000. Okay, and now if we start the code, okay, so if we look at the SEH frame, all good. We continue our execution. Look at the chain now just to see if our SEH got kicked in. Yep, all good. And now if we do F9, it will overwrite the whole stack. See, now everything is got overwritten, by the way. Even look here at the end, we no longer see where's the end of our chain because everything got overwritten. So if now we do shift F9, we feed those bytes into what? Into EIP. So now let's use those 4 bytes which we found and use pattern offset. Okay, so you can use those shortcuts and do this. So what does it say? It says that these 4 bytes, which is the 62, 41, 39, 61, which got pushed into EIP or got stuffed into EIP or whatever you want to call it, they are at the byte 28. So great. So what we need to do now is modify our code, right? We need to modify our code. Let's do this as, yeah, like if you remember, I like to do it this way. I forgot to do it now this time. I don't know why, but yep, let's do so. SEH2 no longer need this. Okay, we'll go back to our friend buff, and this time this is 28, right? And then we'll add, let's add 4 B's. So we'll do 4 B's, right? Because those are the ones we want to push into EIP, okay, right? And then we'll add the rest of the bytes. So we'll do, these are 32, so we have here C multiplied by 968, right? So yeah, 968. I told you my math is not that good. So now if we run this again, our buffer size is 1000 again, good. Everything is working as we want. And now let's just run a couple of executions to make sure all of those crazy stuff gets onto our SEH chain. Yep, all good. And now let's run our so the handler is here. See, FFCC. If we go down, we can see FFCC has FFE4. We go down to FFE4. It has the end of the chain. Okay, so all good. This time, if we hit F9, we got an exception, right? And now, as you can see here, these 4 bytes, because what this needs to do is call the handler now, right? We need to call the handler. So when we pass the handler to it, it's gonna stuff those 4 bytes into EIP. So it's gonna stuff those 4 bytes exactly where into EIP. Now, I want you to look at the stack. So EIP is pointing here. ESP is pointing to this location, right? So it's these 4 bytes, and then we have these 4 bytes pointing where? To our A's, B's, and C's, etc. So what we need to do now is, as you can see here, is these 4 bytes have got pushed over here, right? And these 4 bytes should represent, if I go back to how all of this looks like. So this is the handler, which we overwrote with B's, right? And then the 4 bytes before this are what is the pointer to the next one, the next SEH record. So let's modify our code to have, instead of A's, because now they are A's, by the way, right? So instead of the A's, we'll put the B's here, by the way, just to put something different. Okay, so we can put the B's here, or maybe C if you want. It's both should be fine. And then the B's over here, and then the rest of the data. So just to have an idea of how this is gonna work. So we can do, yeah, let's change actually all of our codes so we can understand the whole concept behind this. So let's say offset, right? Let's call the offset, and this offset is gonna be, I'm gonna do a lot of changes here, and I'm gonna replace this with offset. equals this. Then what I'm gonna do is I'm gonna put the next SEH, okay, the next SEH. I'm gonna put in this one 4Bs, okay, or if you want, we can put 4Cs. So it's up to you, really, it's not gonna matter. And then the SEH will equal 4Bs. So those are 4 also. So we are gonna replace this with the next SEH, just so you can understand the idea, the whole, how all of this is laying off. And then we are gonna put the SEH, right? And then we are gonna put the pad. I'm gonna call this pad, and I'm gonna put this over here. But what I need to do is remove 4 bytes from here. So this is 24. So 24, and then we have C's, which will point to the next SEH. We have P's, which point to the handler itself. And then we have the pad, which will fill everything else. So this will make things easier, and you can understand what's going on. Offset, next SEH, SEH, and then the pad. Let's run the code again. Buffer length is 1000, all good. Everything looks very nice and good. So if we look at execution, and let's see our SEH chain, all good. Okay, so if we run F9, and now if we look at the SEH chain, look what you will see. So you can see that the B's, which point to the next, right? The B's point to the next. Sorry, the C's, which point to the next, is now corrupted, and the first handler, which is this one, is with the B's, right? So the first handler, we go back to Peter. This is now filled with what? With the C's, which is pointing to the next one, but is corrupted. And this one is pointing, this one has the B's, which is supposed to be pointing where? To our exception handler, right? So what we, if we go back to the stack here and we can look at this. So again, see, pointer to the next SEH got overwritten with the C's. And that's based on our shellcode, or our, let's say, our payload here, what we are sending. C's are pointing to the next one. B's are pointing to the handler. So that's why the B pointing to the handler, this is pointing to the next one. Everything looks really good. So what if we go back to Peter's blog and we go a little bit down here, we saw all of this, but here Peter's explaining most of them in WinDebug. I'm using Immunity. He also explained this in OllyDebug, but it's not going to be different than Immunity. It's going to be similar. I think this is Immunity, yeah. So see, this is Immunity. He does use that. So we have the thread environment block. We said block pointing to the beginning of the SEH chain, and then we continue each one until we reach the end of the chain. Let's go down here. I just want to show you how we are going to be exploiting this. So we are going to be triggering exception. The exception will try to call the handler, right? Now, when this is routine comes in, then there's a dispatcher which will try to, it's like a function or something. So it will also have, if you look at it here, so if we, let me just push, let me trigger the handler. So if we do F9, all right, shift F9, I mean. So we, now EIP is trying to do what? It's trying to call what? It's trying to call the, it's trying to execute the handler, the code in the handler. So it's trying to execute the code in the handler, but there is no address called 4242. So that's why it just froze and everything is not working. So in if this was normal code, then it will try to run this code. If it's not gonna solve the problem, then it will go to what? To the next SEH record, and so on and so forth. Now, if you look at the stack, this is the important thing. If you look at the stack, ESP is pointing here, and if you look 4 bytes down, this is where our what? Next SEH is located. So the C's, remember the C? Let's just go back, reminder. The C's is where the pointer to our next SEH code is, right? It's to where the next SEH record is. So what we need to do is we need to find a way to, because we can't do jump PSP. Jump PSP will not do us anything, right? And EAX and EBX, if you see, most of these got zeroed out, by the way. So we can't use those. And yeah, we need to find a way to jump to this address. Why? Because if we follow this in the dump, this is where what our payload is. It's the first 4 bytes is the next SEH, which we can use it to point to our payload. So we can do like a jump to our payload. Again, we now are trying to execute the handler. So the handler, there is no code at 4242. So what happens here is stuck. That's what. So what we need to do here is find some way in to call this line of code, this address. Why? Because if you look at ESP is pointing here, F918, which is this. And if you look 8 bytes below it, so it's ESP plus 8, we can see this is where our next part of the payload is, okay? So what we need to do is we need to find either, let's say, a jump ESP plus 8, maybe that could work, or a pop return will call our C's. Again, a pop return will call our 4 C's. Why? Because it will pop this for value, and then the return will take 4 bytes and try to return to it. So that's how we can call our next SEH. Good. So what we can do now is let's go back to Mona. That's why we have this fancy tool. And if you look at, where is it? Yeah. So see here, find SEH. Let me show you why I was talking about playing with the experiments and the null bytes. So if we do Mona SEH, let's do that. And it's going to be searching all the modules loaded. Don't have a lot, so that's why it's going to come back quickly. And if we go here, so if we go to SEH, now let's look at these. We did find, so we can look at this, by the way, our SEH test. It has rebase disabled because we disabled that. We also disabled safe SEH. We also disabled ASLR. We disabled all of those. NX compat, which is the dip, we also disabled that, and it's not an OSDLL. So everything looks good, but let's look at the code down here. See, these are all from what? SEH. These are all from our code. But the problem is all of them have what? A null byte. See, start null. All of them start with a null byte. So again, for demonstration purposes, really, this is not like how you will be doing this, and we will take other examples, but for demonstration purposes, what I'm going to do, I'm going to go back to my code, and I am going to modify it, because again, the idea in this one especially is I want to explain multiple ideas, multiple things about even the compiler, and then okay, and then where is this? Advanced, and then see how to exploit it. So it's really not about, it's more about what SEH is, these compiler options, and then we'll add, like we'll enable them later on and see how we might be able to bypass them and like use this code. But for now, what I will do is I will put a fixed base address. So if you go back just to see what the addresses were, so if you go back, for example, these, if we take, yeah, so this was the address. So what I'm going to do is I'm going to put the address here, but I'm going to replace these 0 zeros with, let's say, 44. And actually, to make things even easier and to remember them, I'm going to put 55 here. So all our addresses are going to start with 44, 55. Okay, again, this is just for demonstration purposes and nothing more. So if we rebuild the code again, STL override fixed base parameter is an invalid for why is that, by the way? Give me a second to check. So is invalid value for parameter of the linked parameter of type. Did I add? Should I like remove these? Maybe should it be just like this? I forgot really how, or is this something different? Ah, okay, so this is the with the GS thing. So let's put this back. I think it's really not gonna matter this one because I don't remember I had to do any of this. So if I go back here, advanced, not advanced, sorry, general, code generation. So where is SDL? Overriding SDL with GS. Where is control, enable, enable SEH exceptions, basic runtime check. Okay, general. What is the SDL? I keep forgetting many of these, by the way. SDL checks. Where are the SDL checks? That's crazy. I don't remember where these SDL checks are. They should be here. Where code generation. SDL checks. Okay, so here they are. No, disable. I disable them even? I need to disable them. Let's see. Now fixed parameter is of is invalid for the fixed base address. So what do we have this time? Doesn't it accept this? Invalid value for fixed base parameter is of type. Or did I put it in the wrong? Fixed base address? No. Oh, my mistake. Sorry. Should be here is the base address. I know there's something wrong. This is what happens, by the way, when we do. So this is the base address. This is, yeah. Sorry, my fault. Yeah, this is when you do a recording at, what time is it now? It's 5 a.m. kind of. So, okay, so if I do now this, everything should be fine. Please don't tell me you have any problems. Okay, so all good. This time, where is my code? Yeah, so now let's run it again. Okay, so all good. So let's run some executions. Okay, let's look at the stack. Sorry, I mean, let's look at the mono SEH chain. Let's look what we have. Chain has been added, so we can see that definitely. Okay, we can also do mono breakpoint SEH like we did before if you want. Now if we run F9, we should hit the breakpoint. We should hit the violation. So if we pass that. So now what happened is EIP's here, and yeah, so we got back to where we were. So now if we do Mona and we do SEH, see some addresses, right? We want to find some addresses. Let's close this and let's go. So this is done. And if we go to SEH again now if you look at the addresses, they all start with 45 because we told it to the base is 44, 55. Okay. Again, this is just for demonstration purposes, but nothing more. So we can pick any one of these. All of them look good. We can just go with anyone. I'm gonna go with this one. Okay, there's no reason. ASLR false, all false, except etc. So let's go back to our code. Save as SEH3. And now we need to change this with what? With the code we found. So let's do it this way, right? So let's change this to be x12, x19, 19, not 18, hey. And then x55, x44, 44, not 55, please. I'm going to replace these with, by the way, knobs. So we have that, we have all of this, all good. Let's, by the way, put a breakpoint at this address. So if we hit F5, let's just close it and run it again. Okay, so if we hit F5, call this again. Buffer length, all good. Yeah, so now let's go put a breakpoint at this one, this address, which we are gonna, which is C, the pop-up return. And by the way, one thing probably I didn't mention is if you want to look for a pop-up return also, you can right click here and then do search for sequence of commands. So you can do pop R, which is register 32, pop R register 32. So if you want to do it this way, you can also do that. Return, and then if you find, you see, you'll find this address, which is 4455 103D. I'm sure Mona also found that, by the way. 103D. Let's see here. Yeah, see, 103D, which also has pop ESI, pop EBP, pop ESI, pop EBP, return. So you can really also do it this way, but Mona, as you can see, it will show you all of the other addresses available. So it's not gonna matter in our case. We can, again, we can see that we had a breakpoint at pop ESI. Yep, this is where put a breakpoint. Let's go back here. So now if we do F9, as you can see, what happened is we are now at the pop return, right? Actually, let me, this is why when sometimes you just rush into things, let me run it again. I want to show you before the we moved there. Actually, just to look at the stack, look at the stack, the values on the stack before. So let's do this again and then run. Did I run the code again? Why did I run the code? I didn't mean to run the code. I hope this will work this way, by the way. So if we do just, I want to just do a couple of things. I want to see the SEH first. So all good, right? And then I want to see when we overwrite the SEH. Okay. 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 Still. Okay, we still need some more. And by the way, jumping over them, so just to speed up the things. I just want to see when this is gonna get overwritten. There's definitely a better way to do this, but again, I'm the lazy guy. So, yep, it got overwritten. So, great. So as you can see here, 44, 55, 19, 12 is where our SEH handler. If we do mono SEH chain, let's look at that. So we can see mono SEH chain is the handler got written with 44, 55, 9, 12. And then the next SEH, right? This is the next, see, next SEH is actually corrupted because we don't know what is in there. So if we now continue, and now if we hit, let's just do this. So it's waiting for us to shift F9, right? Pass the handler. What's going to happen? We stop where at our pop-up return. So now if we do the pop-up return, look at what's going to happen. So look at FEEC. If we dump that in stack, this is where what all of our other parts of the code is. So CC here, this is where our next SEH, which is what we are going to now end up in EIP. So let's continue. Pop. Now the return will put this in EIP. So put this in EIP. So EIP is now trying to execute this code. Great. So all of this is working correctly. What now we need to do is we need to, so if you look at this, if you look at the code here, if you look at the memory or the code over here, you can see this is where our knobs are. This is where our knobs, all of these are, right? We can look at them. And so what we need is we need a way to jump over this and land here. We need a way to jump from here over these and land in this area, okay? So in this scenario, by the way, we can see that the code, our shell code, we can place it in this area after. But there are cases, which I will explain also later in other videos, our shell code will not be able to be placed over here. It might need to be placed somewhere before, like in this area over here. So make sure that you look at the memory, you investigate things properly, because it's not always going to be jumping from here to this location and then executing the code. Sometimes the area you have over here is very small, so it cannot be used to add your shellcode. So what you will need to do is use this to jump this to area maybe, and then use this area to jump backwards in some other area. I will have videos for explaining that with other examples, but this example is going to be just the first one of SEH to jump into this area. So let's close all this, right? And now modify our shellcode again. This time we need a jump instruction. So if we, let's call this number 4. So there's a short jump, by the way, there's a short jump instead of this. The bytecode for it is EB, right? EB. And then we want to jump over 6 bytes. Okay, if you look back, I need to repeat this again to show you, but we will probably need to, actually let me do that just so you know why do we need to jump. This was like, right, this was 4. Let's just run it again quickly. It's not gonna take a lot of time, and it's better so you can see why am I gonna jump 6 bytes. Let's just run it again. If you, by the way, if you look at Peter's code, you can see that our current SEH handler pointed to the pop-up return. The pop-up return is going to point to our next. This one should be pointing to our shell code. Usually this is like a jump instruction. So if you look down here, by the way, again, like I said, all of this is available here. just that Peter's using a different example, probably now, especially here, using this multimedia application. So if you look down here, where is the code? Where is his code? His code over here somewhere. And you can see he's also explained a lot of more details, more than what I did, by the way. So I highly recommend you check it out. And yeah, where is it? Where is... So next SEH, right, he's putting some breakpoints here just to provide more explanation to people who read the blog. And then if you look at, yeah, probably, yeah, this one, see? This is where he's using the jump 6 bytes. But let's actually see why are they jump 6 bytes. Let's see that ourselves. So if we hit F9, we will end up to our, immediately, to our pop-up return, which is supposed to be our handler, actually, not the pop-up return. But if we do this and then the return will try to execute the code, right? And now if we do the, what did I do? Did I do anything wrong here? Okay, yeah, this is where it got overwritten. Okay, so if I pass the handler now, okay, so this is where we triggered the pop-up return before. Okay, now we are in, yeah. So if you look at this, these are, so these are the bytes where we will be using to add our jump instruction. But we have here 1 byte, 2 bytes, 3 bytes, 4 bytes, right? We have, so we have 4 bytes in here, and then we also need to jump these 2 bytes, right? Because our jump instruction actually is only 2 bytes. So that's why 1, 2, 3, 4, 5, 6. So 6 will land us over here. Let's now, you understood this, let's now modify the code to include our XEB X06. We are going to jump 6 bytes. We can jump more, by the way, it's up to you. Like if you want, we can do 8 because we still have space over here. And then here I'm gonna, because these are 4 bytes, so we need to pad them. So we'll pad them with an op. Okay. And this is our, let's add just some comment here. This is a jump short jump 08 bytes. Okay, so let's run it, the code again. All good. Not sure how long this video is, by the way. I didn't check the timer. Let's do some executions. Okay, let's run the code. We hit this. So let's continue, run the code again. Okay, so now we hit the, where we have a problem. So we will now pass our handler, right? We'll pass our handler. We'll hit the, yep, the pop-up return. So pop, and then the return, we will go to this area. We go to this in the stack, in the dump, sorry. So you can see we will land at this. So we will be executing our EB08, which is the jump. So we will jump over here, landing in this area. But since we added 8 bytes, so we will probably land more further than that. So F7. So now if you look, jump short, and the jump short will go to FEF6. So if you look at that, FEF6 is over here. See, we jumped also over those because if we added 6, we will be landing here because if we added 8, we landed at this area. So if we do the jump, we arrive here, and now we can execute our code. Okay, and now we can execute our code. So that means all we need to do now is add our shellcode. We are getting very close to the end of this video. Let's go back, get our shellcode from, not this one, because we put the shellcode here. Let's use this. So let's do that. So we will be, let's call this shellcode. So offset, next SEH, all good. And then we'll add the shellcode here. So then we'll add the pad. But let's see how much is the pad actually. So this is, we have, let's call the calculator again, minus 99, was it 99? 96, 96, 869, sorry. 869. So we have 869. Let's delete this. And let's run the code. How much is our buffer? Did it start? Okay, I just want to check the size of the buffer. 1000, good. I hope this is the one, by the way, right? Or is this? I just want to double check here. Yeah, it's 1000, because sometimes I've seen that the shellcode is sometimes 1000, sometimes it's 113, so it seems everything is good. So if we continue, if we start the execution, and let's look at our SEH chain, so we can see all the chain is good, no problem. And but if we run F9, let's look at our chain again, just to see what happened. All good still, nothing got crazy yet. But now if we do the execution, this is where our chain got overwritten. So if we go to view SEH chain, we can see it got corrupted. So the first one is pointing to, this is where the handler is. So this is supposed to be the one that gets executed now, but since it does not contain code, it contains our pop-up return. We will end up executing this. So let's F7, pass the handler. The handler calls our pop-up return. So pop, and then return will go to this address here, and the jump F6 will jump to our execution. So if we do, if we take the jump, and then if we run this, I think what we did a mistake, by the way. Yeah, we landed in the middle of our shellcode. So by the way, it's very important that we add some knobs over here. So we landed, by the way, at the beginning of our shellcode, and our shellcode had that code which calls the get PC. So it's probably gonna be, it's not gonna work, by the way. So we'll need to add some knobs over here, 90, and let's just maybe add 16 of them. So we'll need to subtract 16 from here. This becomes 5, 3, 5, 5, 3. Okay. So SEH, then we have knobs, and then shellcode. Okay. So if we run the code now, let's do that and see. Did I do something wrong? I think everything should be correct, right? Everything over here. So yeah, everything is correct. Let's just continue the execution. So now if we go and start our execution a little bit and then just do the again Mona, you can do them the way you want, like here, or just to check everything is okay. Let's continue our execution. So yep, this is for the first time. Let's do this. So our SEH got overwritten. Again, we can do run this to check how they got overwritten. So you can see our handler got overwritten with this, which is the pointer to the not pop-up return. Pop-up return will end up with this value. So this is what's going to happen. So F7. Sorry, we will need to pass the handler. So let's pass the handler. Okay. Now F7, F7. Now the return will go to the jump. Now the jump will end up where in over here, and we have knobs, and then see we didn't now corrupt our payload. So if we do F7, we ended up here. If now F9, we should be running our calculator. So let's modify the code, by the way, just to run it without the debugger. So F5, no, sorry, F5. We should be done, by the way. I know you got tired of listening to me. So if we do this and just do it this way, and F5, we should call our calculator. Where is the calculator? Please, please, please. Where is our calculator? Taking a lot of time, by the way. My system got needs a restart probably. So let's see, where is our calculator? So now we run a calculator by exploiting an SEH exploitation. What I would want you to do, by the way, is to re-enable the properties, go back, re-enable the, what is it? Not date execution. You go to SE and code generation. Yeah, if you enable this, by the way, you should also be able to bypass this, because SEH is one way of bypassing the stack guard or the cookies. So I would recommend doing that as an exercise for yourself. But for now, this is all I have for this video. It's a long video. I hope you learned something out of it, and I hope we'll see you in future videos. Thank you for watching, and I hope you provide me with some feedback. Thank you, and see you next time.